Here, chemical kinetics, we have to discuss classification of rate. Rate can be classified as average rate, and secondly instantaneous rate. This is INT rate and this is AV rate. Now what is AV rate? AV rate is defined over a period of time, and here instantaneous rate, this is defined over a point of time. For better understanding of the average rate and instantaneous rate, we should draw a graph. Suppose that here we have concentration of substance A and here we have time. If we draw the graph, then we get this type of graph. Here we have to first define the average rate. Average rate, suppose that we took a time here t1 and we took another time t2. At t1 time, the concentration of A here is this. At t2 time, the concentration of here, this one concentration. So we can say the average rate is defined between these two times. Here, this is the range of the time in which we define the average rate. So we can say average rate is equal to delta A upon delta T. It means change in the concentration of A divided by time taken. This is the average rate. Now, in this graph, if we want to define the instantaneous rate, suppose that we want to define the rate at this particular instant, at this particular time. Here, at this particular time, the rate is instantaneous rate. Instantaneous rate. Now it is little easy to calculate the average rate, but how we calculate, how we decide the instantaneous rate, this may be little difficult. So we have to know calculation of instantaneous rate. There are two methods. One is coordinate method and another is calculus method. Here, coordinate method means we will draw a tangent at a point of the graph of the curve, at a point of curve, and here calculus method, it means there should be a equation. There should be a equation between concentration and time. Equation means there should be a function. So first of all, we will study the coordinates method of determination of instantaneous rate, INT rate. Here we have a graph. Here is time, here is concentration. We have graph like this. Now suppose here we have a point at which we have to decide, we have to determine the instantaneous rate. This is point at which we want to determine the instantaneous rate. So what we have to do? We have to draw a tangent. This is the tangent, like this. This is the tangent. Now this is the angle theta. We can say the slope of this tangent is equal to tan theta, and this slope will be equal to rate. And what type of rate? Instantaneous rate, which is dA upon dt. So without drawing the tangent, it is not possible to determine the instantaneous rate. The second method is calculus method. It means the equation that must be given between the concentration and time. So here calculus method. Here in this method, an equation should be given between concentration and time. What you have to do now? You have to differentiate this equation with respect to time. You have to differentiate the equation with respect to, this is nothing but with respect to time. You have to differentiate this equation with respect to time. Thank you very much. Thanks a lot.